Yeah, dear students, already we have completed our first chapter. The name of the chapter is Electric Charges and Fields. In that chapter, we have studied about the electric charge, properties of electric charges, and interaction between two charges. That means force between two charges, and thereafter electric field, and thereafter dipole, and thereafter torque experienced by the dipole. Okay, thereafter electric flux and applications of electric flux also. These all things we have studied in our previous class. That means first chapter. And thereafter today we are going to begin freshly with the electric potential and capacitances chapter. Electric potential and capacitances. This is the second chapter we are having. Now in this chapter mainly sir what we have to study. Okay, let me see here. Now before going to discuss about the chapter, first recall what is the charge. Charge is nothing but that is the property on a substance. Property of a substance. Property of a substance. Now due to that property, okay, what will be happen means one substance can be apply the force on another identical or different substance also. For example, what kind of force it can apply means that force is nothing but electrostatic force of attraction or repulsion. If the like charges, they were attract with each other. If the unlike charges, they were repel with each other. Okay, now here what is the final conclusion? Okay, final conclusion is nothing but okay, charge is a property on a body that causes the force on other charged body. One charged body can causes the force on another charged body. Now in this chapter we are going to charge means that is the property, right? In this chapter electric potential, about electric potential and capacitance. Okay, about this we have to study. First, in beginning of the classes, let me discuss about the electric potentials, capacitance later we will discuss. Now, very first one, how to begin the chapter means, chapter we must be begin with a definition. The name of the definition is nothing but electrical or electric potential. Now, this one also known as electrostatic potential also. This one also known as electrostatic potential. Sir, electric potential is denoted by which letter means electric potential can be denoted by a letter. Okay, that letter is nothing but V. V is the notation of the electric potential. Sir, how to understand the electric potential? Okay, we just see here. Now, what is the electric potential means? First of all, here what I am taking here means I am going to take here that is nothing but okay Q, capital Q. One of the charge I am taking. Of course, what kind of charge I have taken means whether it is positive or negative means one positive charge I have taken. The name of the charge is nothing but capital Q. Suppose if you take a charge at any point, okay, we have studied in our previous chapter. Okay, around the charge what will be existed means around this charge a kind of field can be existed. Okay, that kind of field is nothing but here. Okay, what we can call it as means that kind of field can be called it as electric field. That means around this positive charge, what will be existed means electric field will be existed. Okay, fine. Thereafter, here from this charge, see you are just observing the diagram. From this charge, okay, what I am going to take here means okay, one infinity point I am taking from this charge. Okay, one infinity point I am taking. Infinity point from plus capital Q, positively charged Q charge from this charge at a distance infinity. Okay, what I am going to take here means here I am going to take another charge. What is the charge means? That is nothing but test charge, unit positive charge. This is also unit positive charge is being at a infinite distance from this charge. Okay, fine. Sir, this is unit positive charge. Unit charge positive charge means whose magnitude is equal to 1. Its magnitude is equal to 1 coulomb. 1 coulomb we can take it as. Coulomb is the unit of charge. Okay, fine. Now here this is completely what is that means. Okay, electric field is there around this positively charged. Okay, electric field is there. Now here we have to bring this unit positive charge from where to where. This unit positive charge we have to bring from infinite distance to a given point in electric field. A given point in electric field. Of course, this point is being at a distance small r from the source charge, right? Now here unit positive charge is there. This unit positive charge we are bringing from infinite distance to a given point in the electric field. Okay, to here we are bringing the unit positive charge. In that case, what happened? Let me see. Actually, this is the positively charged positive charge. This is positively unit charge. Okay, unit positive charge. Here at this point, now just look at here. This is nothing but capital Q charge. Due to this capital Q charge, later I will discuss. Due to this capital Q charge, at this point, what is the electric field means? That electric field is nothing but E. Sir, what is the direction of electric field E means? For a positive charge, electric field is outward direction, away from the charge. That means here electric field we have to show, okay, away from the charge. Like this we have to show. Now this is nothing but electric field direction. Okay. Now here unit positive charge we have to bring from infinite distance to a given point in the electric field. Of course, opposite to the direction of electrostatic force of field. Opposite to the direction of electrostatic force of field. That means in order to bring the unit positive charge from infinite to a given point in the electric field, of course, against to the electrostatic force of this field. Okay, ಈ field ಗೆ against ಆಗಿ ಈ ಚಾರ್ಜ್ ಈ ಪಾಯಿಂಟ್ ಹೊರಗೆ ತರಬೇಕು ಅಂದ್ರೆ okay, we have to do some work. Some work is required to bring the unit positive charge from infinite distance to a given point. That work is called here electric potential. Okay, that work is called here electric potential. Okay, just listen to me how to define the electric potential means. Okay, electric potential at any point in the field is defined as the work done to bring a unit positive charge from infinity to that point against the electrostatic force of field. That means electrostatic force of E field to electrostatic force ಗೆ against opposite direction ಅಲ್ಲಿ ಈ ಪಾಸಿಟಿವ್ ಚಾರ್ಜ್ ಈ ಪಾಯಿಂಟ್ ಗೆ ತರಬೇಕು ಅಂದ್ರೆ ಏನು ಮಾಡಬೇಕು? ವರ್ಕ್ ಮಾಡಬೇಕು. ಆ ವರ್ಕ್ ನೇ ಏನು ಅಂತ ಕರಿತೀವಿ ಅಂದ್ರೆ ನಾವು ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಅಂತ ಕರಿತೀವಿ. ದಟ್ ಮೀನ್ಸ್ electric potential comma V is equal to what we can write? V is equal to we can write work done. That means the amount of work done to bring the unit positive charge from infinite to a given point in the electric field. Now to bring the unit positive charge from infinite to a given point in the electric field, whatever the work we are bringing, that work is said to be, that work is equivalent to here potential. That means work, electric potential is nothing but what we can write means work per unit positive charge. Of course, electric potential V is equal to what we can write means we can write work done by the charge. Work done by the charge. Okay, now this is nothing but here electric potential. Here electric potential at any point in the field is defined as amount of work done is required to bring the unit positive charge from infinity to a given point in the electric field against the electrostatic force of field. Okay, now this one is said to be here electric potential. Of course, electric potential is what type of physical quantity means. Electric potential, okay, is a look at electric potential is a what type of physical quantity means. Electric potential is a scalar quantity. That means electric potential is having only magnitude but no direction. Okay, right. Sir, what is the unit of electric potential means? Unit of electric potential, that means its unit is which unit? SI unit. Okay, its SI unit is what we can write now? That is nothing but volt. Volt symbolic representation is nothing but we have to write capital V. Capital V is nothing but unit of the potential, electric potential. Now this is the electric potential definition. Once again, okay, listen the electric potential definition, how to define the electric potential. Right, electric potential at any point in an electric field is defined as the work done to bring a unit positive charge to carrying the unit positive charge from infinity to a given point. Against the electrostatic force of field. Okay, that means here this is the positive charge and this one is nothing but positive charge. This positive charge we are bringing to here. This is also positive charge, this is also positive charge. Two are like charges. Like charges are repulsed with each other. So in that case, this capital Q charge is repulsed to, okay, this just charge in which direction? In the direction of electric field. Okay, like this. That means here we are bringing the unit positive charge, okay, from infinity to a given point, of course, opposite in the direction of electrostatic force of that field. That is said to be here electric potential. Yes, I will give the definition also here itself. Yes. Look. Yeah, once again, electric potential definition. Look at here. Electric potential at any point in the electric field is defined as the work done in carrying it or bringing it or moving it. Anyone can. In carrying a unit positive charge from infinity to that point against the electrostatic force of field. Now related to its explanation has given here is okay, right there. Sir, mathematically how to write electric potential? Electric potential V is equal to work done by charge, or work done is equal to, okay, electric potential into charge. Very, very important formulas. Okay, remember. Next one, it is a scalar quantity. Electric potential is a scalar quantity. It is having only direction, only magnitude, but no specified direction. Now, its SI unit is volt. Volt is the unit of electric, okay, potential. Okay, right. Thereafter, we are having the continuation of this topic. What is that means? Electric potential difference. What is the electric potential difference? We have to define. Once again, to define this one, okay, what I am having here means I am having here one charge here. Now, what charge I am having? The charge name is nothing but capital Q. That is positive charge. Now, from this charge, here I am considering a point. Okay, that point is nothing but, okay, some point is there. Okay, no need to be taken. Right. Now, from this unit positive charge at infinite distance, see what is there? Here one unit positive charge is there. Where it is at this point, one unit positive charge is there. Now, this unit positive charge we are bringing from where to where? We are bringing from, okay, infinite distance to a point A point. At a point A, we have brought. Okay, sir, due to this charge at this point, what is the electric potential? Electric potential is nothing but, of course, we can take V suffix A. And thereafter, nearby this point, see, there is another point is there. What is that point? That is nothing but B point is there. Now, okay, here at this point, whenever you bring the unit positive charge from infinity to this point, in that case, okay, the potential, the work done, what we have done means VA work done we have done. Next, in order to move this unit positive charge from where to where? Okay, from point A to point B. in order to move the unit positive charge from point A to point B, okay, from here to here, what we have to do? We have to do the work done, okay, through a small distance or displacement, okay, for a small displacement from A to B, to move the charge from A to B, okay, there is a requirement of a small work done. That work done is nothing but what we have means V suffix B. That means here one potential is there, here one potential is there. Okay, between the two potential points, we are moving the charge in between the two potential points. Okay, in between the two potential points, suppose if you are moving the charge means surely there is a difference in those potentials. Okay, here, sir, how to define the electric potential difference means electric potential difference can be defined as the amount of work done to move the unit positive charge from one point to another point against the electrostatic force of field. Okay, same. Okay, one point to another point ಗೆ ನಾವು okay ಈ ತರ ಚೇಂಜ್ ಮಾಡಿದ್ರೆ that means charge ಮೂವ್ ಮಾಡಿದ್ರೆ ಅದನ್ನೇ ನಾವು ಏನಂತ ಕರೀತೀವಿ ಅಂದ್ರೆ electrostatic potential difference. That means electric potential difference ಅಂತ ಕರೀತೀವಿ. Right, sir, ಈ ಡೆಫಿನೇಷನ್ ಹೇಗೆ ಬರೀಬೇಕು? Listen. Yeah, listen to me. See here the definition. Electric potential difference. Electric potential difference can be defined as the amount of work done to moving the unit positive charge from one point to another against the electrostatic force of fluid. Right here. Now from one point to another point to move the unit positive charge. From point A to point B to move the unit positive charge. Whatever the work done is required, that work done is said to be here electric potential difference. So electric potential difference between 2 points. Electric potential difference between these 2 points is equal to the difference between the 2 points. Potential difference between the 2 points. Electric potential between these 2 points is equal to potential difference between the 2 points, that equal to okay work done in order to move the charge, work done in order to move the unit positive charge from point A to point B. That is said to be electric potential. Yes, ma? Yes. Make a note. Any more doubts? Just ask me. Now we are having continuation of the topic. First we have discussed electric potential, next to electric potential difference also. Now the question is nothing but next the expression we are having electric potential due to a point charge. Whether you have remembered or not, we have derived the expression for electric field due to a point charge also, first chapter. What we have derived here means electric field due to a point charge is 1 by 4 pi epsilon naught charge divided by r square. Okay, we have derived the electric potential, that means electric field due to the point charge. Now here we have to derive the electric potential due to a point charge. We have derived 1 or 2 times. Okay, this expression they have asked in the question. Okay, question paper setters are asked in the examination mark. So just to keep it in mind. Very simple one, you just follow me. Okay, until the last explanation, the last derivation. Okay, you never miss the video. Just keep on watch the video continuously. Now first, electric potential due to a point charge. Here one point charge is there. The name of the charge is nothing but capital Q. Capital Q point charge is there. Now from this point charge, okay, at a distance r, here one point P is there, point P considering. At this considerable point, we have to measure the electric potential. E charge in the E point hatra electric potential no measure ಮಾಡಿ. That means expression formula no derive. That is our intention. Now from this charge, okay, here at infinity distance what is there? Here one unit positive charge is there. The name of the unit positive charge is nothing but Q naught. Okay, right. Now this unit positive charge we are bringing from where to where? From infinite to a point. From infinite to a point A. From infinite to a point A, what we are doing means we are moving the unit positive charge. Okay, this unit positive charge Q naught, we are moving from infinity to a given point. Okay, fine. Sir, from this, okay, considerable charge. From this charge, okay, at what distance? Okay, this point charge has located. At what distance from the charge? At what distance? Okay, unit positive charge has located or we brought means we brought up to a distance is nothing but how much more x. At a distance x, there is a charge. Now, here this is a positive charge and this is also a positive charge. Two charges are there. The two charges are repel with each other. So this capital Q charge, this source charge is okay experiences or applies a repulsive force on the test charge. So here just see here electrostatic force, right? Look at here. Electrostatic force due to capital Q on Q naught. Okay, is nothing. What is the electrostatic force formula? F equal to 1 by 4 pi epsilon naught capital Q into Q naught divided by distance. Distance between the two charges. What is the distance between the two charges? X. So I can write x square. Of course, I know that one more point. Q naught is nothing but unit positive charge. Unit positive charge means whose value is 1. So the same one I am going to write 1 by 4 pi epsilon naught capital Q divided by what I can write x square. Okay, here in bracket you write since Q naught equal to 1 coulomb unit positive charge. I said I. Okay, right. Now that, sir, in between these two charges, what I have calculated electrostatic force, that is nothing but 1 by 4 pi epsilon naught Q divided by r square. That is equation number 1. Thereafter, here we are moving the unit positive charge from where to where? Okay, I am moving the unit positive charge from A to P. I am going to move. Okay, from A to P, suppose I am moving the unit positive charge means how much distance is covering here? Dx distance is covering. Of course, here charge is experiencing the force in which direction? Away. Repulsive force means away. Okay, E charge. Repel means pushing out. Attracting means okay, taking towards. Next, here in this direction force is applying. Okay, we are displacing the unit positive charge from where to where? From point A to point B. In that case, in order to move the charge, unit positive charge from one point to another point in the electric field. In that case, what we have to do? We have to do the small work. Okay, right. Look at here. Right. The small work done to move the Q naught, charge Q naught, okay, from A to P, through a small distance or displacement, both we can take note of. Distance is what is the small work done? Small work done for small distance is nothing but small work done. dW is equal to work done is equal to, what is the formula? Sir, work done is equal to formula is nothing but force into displacement. Dot product of force into displacement. We get it. Okay, here force is nothing but, what is the force? F bar is the force. Displacement. What is the displacement from A to P is nothing but dx bar. We can Next, sir, dot product between two vectors w is equal to what we can write? Fx cos theta. Fx cos theta. So this one will becomes how we can write means dw is equal to fx, sorry, f dx into cos 180 degree we can. Sir, why we have to write 180 degree? Here means cos theta. Okay, bracketally you write it since theta is equal to 180 degree. Why 180 degree? Force is in this direction. Okay, displacement is opposite direction. If the two vectors are in opposite direction, then the angle between the two vectors is nothing but 180 degree. So dw is equal to minus what we can write? F dx we can write. Of course, that is equation number 2. Now dw, small amount of work done. Point A to from point A to point B to move the charge. Okay, the amount of work done, small work done is nothing but okay F into dx. Now this is another point. Small work done we have. Then what is the total work done in order to move the charge from infinity to point B? That is from infinity to this given point P. To move the charge from infinity to this given point P, how much work done we have to do? For small displacement, the work done is nothing but minus ftx. Okay, from infinity to this point, what is the work done? Okay, come to the point. Right. Total work done. Total work done to move charge q naught from infinity to point P, infinity to point P. Okay, total work done to move the charge from infinity to point P. They were asking. So here to here work done is nothing but dw. In similar way, here to here another dw. Here to here another dw. Here to here another dw. Like this, some number of small work dones will be okay considered here. Now all number of work dones we have to add up, we have to make the summation, we have to integrate them, then only we may get answer. So from infinity to the point P, this point P is located at a distance r from the capital P. Right? ಇಲ್ಲಿಂದ ಇಲ್ಲಿವರೆಗೆ ಚಾರ್ಜ್ ಮೂವ್ ಮಾಡಬೇಕಂದ್ರೆ ಟೋಟಲ್ ವರ್ಕ್ ಡನ್ ಎಷ್ಟು ಅಂದ್ರೆ ಇಲ್ಲಿಂದ ಇಲ್ಲಿವರೆಗೆ ಎಷ್ಟು ವರ್ಕ್ ಡನ್ಸ್ ಎಕ್ಸಿಸ್ಟ್ ಆಗುತ್ತೋ ಆ ವರ್ಕ್ ಡನ್ಸ್ ಇಂಟಿಗ್ರೇಟ್ ಮಾಡಬೇಕು. ಸೊ ಹಿಯರ್ ಇಂಟಿಗ್ರಲ್, look at here, this is the symbol for integral. Integral dw is equal to, we can write integral where to where work done we have to measure? Work done we have to measure from infinity to okay to a distance of r. Infinity to a distance of r we have to measure. So range of integration ಎಲ್ಲಿಂದ ಇಲ್ಲಿವರೆಗೆ ನಾವು ಮೆಸರ್ ಮಾಡಬೇಕಂದ್ರೆ ಇಲ್ಲಿಂದ ಇಲ್ಲಿವರೆಗೆ ಮೆಸರ್ ಮಾಡಬೇಕು. ಸೊ from here to here r which is and integral dw equal to what is formula? Minus f into dx, of course. Next to continuation, integral okay infinity to r okay minus of f is nothing but what is the formula is there? 1 by 4 pi epsilon naught capital Q divided by okay what is there? X square is there into dx, right? This one f value 1 by 4 pi epsilon naught Q divided by x square I have substituted here, remaining dx I have written here. Next thereafter integral dw, right? Formula is nothing but just see here integral dx equal to formula is nothing but x. Integral dw is nothing but w. So work done w equal to Q you take it common, 1 by 4 pi epsilon naught you take it common, minus also you take it common. So Q divided by 1 by 4 pi epsilon naught if you take it common. So continuation integral infinity to r of 1 by x square will be there. 1 by x square, how we can write? We can write x power minus 2 into what we can write? Dx. Of course, in integrations we are having the formula integral x power n dx equal to formula is nothing but x to power n plus 1 divided by n plus 1 is the formula. Now according to this, okay, what we needed, x to power minus 2 plus 1 divided by minus 2 plus 1. So x to power minus 1 divided by minus 1. So minus x to power minus 1. So minus into x to power minus 1 is nothing but what we can write, 1 by x we can write. Yes, now from this one, work done is equal to minus q divided by, 4 pi epsilon naught into x square, x power minus 2 into dx. Okay, x integral x power minus 2 into dx will becomes minus 1 by x. Here minus 1 by x we can write. Of course, minus you just write on this side. Okay, thereafter limits are nothing but, here lower limit is infinity, upper limit is nothing but r. So minus into minus cancel, plus equals. Next, w is equal to q by r, 4 pi epsilon naught, 4 pi epsilon naught into 1 by, upper limit is nothing but 1 by x is there. Instead of x, once you write upper limit, that is nothing but r minus 1 divided by lower limit is infinity. Anything by infinity is nothing but 0. So work done is nothing but remaining what we are having, 1 by 4 pi epsilon naught q divided by what we are having r. Now this is the work done to bring the unit positive charge from infinity to point P. ಈ ಇನ್ಫಿನಿಟಿ ಇಂದ ಪಾಯಿಂಟ್ P ಗೆ q ನಾಟ್ ಚಾರ್ಜ್ ತರಬೇಕು ಅಂದ್ರೆ ಎಷ್ಟು ವರ್ಕ್ ಮಾಡಬೇಕು, ದಟ್ ಇಸ್ ನಥಿಂಗ್ ಬಟ್ 1 by 4 pi epsilon naught q divided by r. Thereafter, by the definition of potential, by the definition of potential, potential, what is the definition for potential? Okay, potential definition is equal to work done. Hence v is equal to the work done plus v equal to what I have written 1 by 4 pi epsilon naught, okay, q divided by r is nothing but electric potential. See, electric field means 1 by 4 pi epsilon naught q divided by r square. Electric potential means 1 by 4 pi epsilon naught q divided by r, not r square. Now that is the expression. This expression is important for 5 marks. Okay, very very important mark. Any more doubts, just call me. Right. This electric potential, it is scalar. Scalar means if you take here positive charge, electric potential will becomes positive. If you take here negative charge, electric potential is negative. If you take positive charge, electric potential is positive. If you take negative charge, electric potential is nothing but negative. Yes.